Here we have the hanger yoke assembly for air, nitrous and oxygen on the Mindray A7 workstation. So let's have a look at the individual parts of the hanger yoke assembly. So this is the hanger yoke assembly wherein there is a gate. So this is the gate. Alright, this is a gate with the retaining screw in it. So as you can see, this is the retaining screw. This retaining screw helps to fit the cylinder onto the hanger yoke assembly. This retaining screw has to be fitted into the conical depression of the valve. Alright, so there is a conical depression here and the screw is fitted into the conical depression and it on the valve, and it helps to keep the valve in place and helps to keep the cylinder in place on the anesthesia workstation. Let's have a closer look at the parts of the hanger yoke assembly. So here we've opened the gate, and as you can see that there are these two pins. Alright, so this is belonging to the pin index safety system. These are the pins for oxygen. So the pins are located from right to left, alright, in the arc form. So from right to left there are pin number 1, 2, 3, 4, 5, 6 in the similar way. So since this is oxygen, the pin number is 2 and 5 for oxygen. Here you can have a look that there is an opening. This opening is the nipple in which the valve fits into, and gas will flow through this nipple into the anesthesia workstation. This circular disc is the Bodox seal. So there's a soft material over here which is of neoprene, and there is a metallic ring around it. So this Bodox seal will prevent the leaking of gases when the gas moves from the cylinder into the anesthesia workstation. The pin index is a safety mechanism over here, as well as this Bodox seal is one of a safety mechanism over here. Now let's have a look at the nitrous cylinder. This is the nitrous cylinder which has been loaded onto the anesthesia workstation. This cylinder is blue in color, so it's color coded. Alright, the shoulder is blue and the body is blue as well. Now the material of the cylinder that is usually used is molybdenum steel. It is an alloy, so it's molybdenum and chromium alloy, which is known as molybdenum steel. So this molybdenum steel will give a lot of strength to the cylinder and as well as keep the cylinder lightweight. Here this is the handle. Alright, so this handle you have to fit it on top of the valve. Okay, so this handle is used to open and close the cylinder. So when we go anti-clockwise, the cylinder will open and the gas will enter from the cylinder into the machine. If we close it, that is we go we close it, that means we go clockwise, and the gas flow will stop. Here we have two cylinders. We have the nitrous cylinder and we have the oxygen cylinder. As you can see, the oxygen cylinder has got white shoulder and a black body. The nitrous cylinder has got a blue shoulder and a blue body. It's completely blue in color. The cylinder base is flat. As you can see here, it is flat base cylinder. These are the type E cylinders which are attached on the anesthesia machine. This is the cylinder valve. So this is the stem. This is the stem which is to which the handle is attached and the cylinder can be opened or shut. This is the conical depression. So it is in this conical depression that the retaining screw of the hanger yoke assembly is screwed on and the cylinder is attached to the anesthesia workstation. This is the small device that you can see over here is the pressure relief device, the pressure relief valve. So the pressure within the cylinder exceeds, it is this valve which will release the excess pressure. Here on the other hand, over here, this is the other side of the valve itself. So over here, this is the pin in the holes for the pin index, alright, which will receive for the pin index safety system. Whereas this is the port through which the gas will enter will leave from the cylinder and enter into the workstation. So this is the port and this is the holes for the pin index, and this is the conical depression to which the retaining screw is going to be